Okay. So in this lecture, we are going to discuss about the assumptions which we make for the derivation of the bending equation. So what are those assumptions? This is what we are going to discuss in this video lecture. So what are those assumptions? Let us start from something which is basic, and these three are common for most of the derivations which we are going to make. Is that okay? So these are the assumptions based on which we are going to derive the bending equation. So the first assumption is that the beam is prismatic. What is the meaning of the word prismatic? What is the meaning of the word prismatic? The meaning of the word prismatic is the area of cross section, the area of, like this book is a prismatic member, okay? Why is that so? Because the area of cross section is same throughout. Is that okay? So what is the meaning of the word prismatic? Prismatic means that the area of cross section of the beam is uniform along the length of the beam, and it is also a straight line. Okay? The second assumption is homogeneous. So what is the meaning of the word homogeneous? Homo means same and genus means property. So those properties which we have studied about the material are same throughout. Okay? So what is the meaning of the word homogeneous? Homo means same and genus means property. So if the material property is same throughout, we call those types of material as homogeneous. But normally it doesn't happen because there are some kind of manufacturing defect or some kind of minor cracks, but we are assuming in our derivation that the material is homogeneous. Okay? It is same throughout, the properties are same throughout. The third point which we had discussed earlier, that the beam is under pure loading condition. I hope you understand what is the meaning of the word pure bending. Pure bending means that the bending moment is constant and shear force is zero. I had explained this in the previous video. If you have not seen it, please go and refer to it. What is the meaning of the word pure bending? Pure bending means the bending moment is constant and the shear force is zero. Is that okay? The next point is loading is within linearly elastic zone. This we will discuss, but this is quite understood because we have to find the relationship between the strain and the stress. The strain developed due to the loading condition and the stress. So this relationship which we are going to derive will be applicable only when the loading is within the proportionality limit. Okay? Is within the linearly elastic zone. This is valid only when the stress and strain behavior is linear. Is that okay? So these are few things which a part of this. These three are almost similar for all the derivations. So you can by heart it. The next, which is quite unique for bending, deformation of cross section within its own plane is neglected. So when you bend something, what will happen? When you bend something, I'll demonstrate it with the help of a figure. When you bend something, suppose this is the actual cross section. Because of the loading, it may become somewhat like this. Is that okay? Somewhat like this. We are neglecting this because this is going to be very small. Okay? So we are neglecting this variation. Deformation of cross section within its own plane is neglected. But in reality, if you exaggerate and see the cross section, this is what you are going to find. The dimensions are going to change. Is that okay? So, but we are assuming that this is not changing. The next assumption is the cross section area is symmetric. Like you can see, the cross section of this particular book is symmetric about this line and this line. Okay? So this cross section is symmetric about this line. Is that okay? So this is what we are talking about, that the cross sectional area is symmetrical. The next point of our concern is all cross section remains plane and perpendicular to the longitudinal axis. Because of bending, if you exaggerate, if you make it too large, wrapping can happen. Okay? Wrapping means something like, means it will become somewhat like this. Okay? This is what is called wrapping, somewhat of this kind. Okay? So this is called wrapping. Okay. So this should not happen. So, but this will happen. In reality, it does happen. To some extent, it does happen. So we are making this assumption that all cross sections remain plane and perpendicular to the longitudinal axis. Is that okay? So what we are assuming, that the cross section remains plane. It does not wrap like this. Okay, it does not become like this. It remains plane and it remains perpendicular to the longitudinal axis. It remains plane and perpendicular to the longitudinal axis. And the last but not the least, plane of symmetry of cross section is plane of bending. The bending is happening, this bending is happening in the plane of symmetry. If this is the plane of symmetry, the bending will happen in this plane. Is that okay? The bending is happening in the plane of symmetry. So I hope I have explained all the points. Just very quickly I will summarize. The beam should be prismatic, the material should be homogeneous, the condition or loading condition should be pure bending condition. What does it mean? The shear force is 0 and bending moment is constant. Loading is within the linearly elastic zone. Deformation of the cross section is within its own plane is neglected, even though it does happen, but we are neglecting it. Cross section area is symmetrical, okay, and all cross section remains plane and perpendicular to the longitudinal axis. Plane of symmetry of cross section is plane of bending. Okay, thank you.